Transportation Exam Prep 2026. Hello, I know the Transportation P exam feels like a mountain of manuals and confusing formulas. You've got AASHTO, the HCM, and the MUTCD all staring at you. But guess what? Most of these problems come down to simple logic and knowing where to look. Today, I'm going to walk you through the core concepts so you can walk into that exam room with total confidence. This is just a part of the complete course. You can get the link in the description for the complete practice questions with explanations, which will help you get your certification. I have also put a link to my Udemy practice test and a special Etsy visual guide for those who like to see how things work with pictures. Section 1. Horizontal and Vertical Curves, Geometric Design. Details, Theory and Concepts. Geometric design is the bread and butter of the transportation exam. We are basically looking at how we build roads so cars don't fly off them. First, let's talk about horizontal curves. These are the curves you see when a road turns left or right. A tighter curve has a smaller radius. When a car turns, physics wants to push it outward. To stop this, engineers use superelevation. This is just a fancy word for tilting the road. Think of a station as a marker on the road every 100 feet. If you are at station 10 plus 50, you are 1,050 feet from the start. Calculating the PC, point of curvature, and PT, point of tangency, is a guaranteed question. Next, we have vertical curves. These are the hills, crests, and the valleys, sags. The big concern here is sight distance. On a crest curve, a hill, you need to make sure the curve is flat enough so a driver can see an object on the road in time to stop. This is called SSD, stopping sight distance. I see many students struggle with the math here, but in my Etsy visual guide, I have a curve cheat sheet that shows you exactly which formula to use based on the curve type. It makes the K value math look like first-grade arithmetic. Practice questions. 1. What does the term superelevation mean in road design? Answer. It is the banking or tilting of a road curve to help cars stay on the track. Explanation. It uses gravity to counteract the outward force felt by a vehicle during a turn. 2. If a curve has a very small radius, how does that affect the safe speed? Answer. The safe speed decreases. Explanation. Tighter curves require lower speeds to prevent vehicles from losing control or skidding. 3. What is a station in civil engineering? Answer. A standard distance of 100 feet used to measure a project's length. Explanation. Stations make it easy to talk about specific points along a long highway without using giant numbers. 4. Why are crest, vertical curves dangerous if they are too sharp? Answer. They block the driver's view of the road ahead. Explanation. If the hill is too steep, you won't see a stopped car or a person until it is too late to stop. 5. What does SSD stand for? Answer. Stopping sight distance. Explanation. This is the total distance a driver needs to see, react, and bring the vehicle to a complete stop. Section 2. Traffic capacity and level of service, loss. Details, theory and concepts. Now, let's look at how many cars a road can actually handle. This is called capacity. But as engineers, we don't just care about the number of cars. We care about the feeling of the drive. We measure this using loss, level of service. Loss is graded like a school report card, from A to F. 1. Loss A. You are the only person on the road. You can go as fast as you want. 2. Loss C. There are other cars, but you can still change lanes easily. 3. Loss E. The road is at full capacity. One person tapping their brakes causes a huge backup. 4. Loss F. Total gridlock. The stop and go nightmare. To find the LOS, you usually have to calculate the free flow speed. This is how fast people would go if there were no traffic. Then, you adjust that speed based on things like lane width and how close the trees or walls are to the road, lateral clearance. One tricky area is peak hour factor, PHF. Traffic isn't a steady stream. It comes in bunches. The PHF tells us how bunched up the traffic is during the busiest 15 minutes of an hour. 00 means the traffic is perfectly steady. 70 means everyone is arriving at the exact same time. In my Udemy practice test, I have several loss tables just like the ones you will see in the real exam. Practicing how to read these tables is the fastest way to save time during the test. Practice questions. 1. Which level of service, LOS, represents a road that is at its maximum capacity? Answer. Loss E. Explanation. At loss E, the road is full, and any small disruption will cause a total breakdown in flow. 2. What happens to the loss when the density of cars increases? Answer. The loss grade gets worse, moves toward F. Explanation. More cars in a smaller space means less room to maneuver and slower speeds. 3. What is the peak hour factor, PHF, used for? Answer. To account for the fact that traffic is not uniform during an hour. Explanation. It helps engineers design for the busiest 15-minute surge rather than just an average. 4. If you widen the lanes on a highway, what generally happens to the free flow speed? Answer. The free flow speed increases. Explanation. Drivers feel safer and more comfortable in wider lanes, so they naturally drive faster. 5. What is the definition of headway? Answer. The time gap between the front of one vehicle and the front of the next. Explanation. It is measured in seconds and helps determine how tight the traffic flow is. Section 3. Traffic Control Devices and Safety, MUTCD. Details, Theory and Concepts. This section is all about the MUTCD. That stands for the Manual on Uniform Traffic Control Devices. It's basically the rulebook for signs, signals, and road paint. The exam loves to ask about sign colors. 1. Red, stop or prohibited. 2. Closing parenthesis dot. 3. Orange, construction. 4. Green, directions, information. 5. Blue, services, like food or gas. You also need to know about warrants. A warrant is a checklist. You don't just put a traffic light at an intersection because people are complaining. This means the traffic volume or the number of crashes must hit a certain number before the law allows you to install a signal. We also look at clear zones. This is the empty space on the side of the road. If a driver loses control, the clear zone gives them a chance to stop or recover without hitting a tree or a bridge pier. If you can't provide a clear zone, you have to put up a guardrail. Safety math often involves crash rates. It sounds hard, but it's just a simple ratio. My ETSI visual guide has a page called The Sign and Signal Guide that simplifies the most common MUTCD rules into easy-to-read pictures. Practice questions. 1. What color is used for temporary traffic control signs in work zones? Answer: orange. Explanation: orange specifically alerts drivers to construction and maintenance areas. 2. Does satisfying a warrant mean you must install a traffic signal? Answer: no, it just means you may install one. Explanation: warrants provide the justification, but the engineer still uses professional judgment. 3. What is the main purpose of a clear zone? Answer: to provide a safe, unobstructed area for vehicles that leave the roadway. Explanation: it reduces the chance of a serious accident if a car veers off the road. 4. Which sign shape is reserved exclusively for the stop sign? Answer: the octagon, 8 sides. Explanation: the unique shape allows drivers to recognize it even if the sign is covered in snow or seen from the back. 5. In traffic signal timing, what is change interval usually referring to? Answer: the yellow light. Explanation: it is the time provided for drivers to either clear the intersection or come to a safe stop. You're doing great. That covers our first 3 big topics for the P Transportation exam. Geometric design, traffic flow, and safety are the pillars of the test. Don't forget to check the links in the description. The full course, access the rest of the sections and deep dive answers. Udemy practice test, get used to the timed pressure of the P exam. ETSI visual guide, use my drawings to memorize the formulas without the headache. Section 4, intersection geometry and sight distance. Details, theory and concepts. Intersections are the most dangerous parts of a road because that is where paths cross. As an engineer, your job is to make these crossings as safe as possible. One of the most important things we check is intersection sight distance, ISD. This is different from the stopping sight distance we talked about earlier. ISD is the distance a driver on a side street needs to see down the main road to decide if it is safe to pull out. If there is a big bush, a building, or a parked car in the way, we call that a sight triangle, obstruction. You have to make sure that triangle is clear so drivers don't pull out in front of a speeding truck. We also look at left turn lanes. If you have a lot of people turning left, they block the people going straight. We add a pocket or a turn lane to get them out of the way. You will often have to calculate how long that lane needs to be so it doesn't overflow. Then we have roundabouts. The exam loves these because they are becoming very popular. In a roundabout, the most important rule is that traffic inside the circle has the right of way. Roundabouts are great because they force people to slow down, and they eliminate the T-bone crashes that happen at regular traffic lights. It shows you exactly how to draw the lines to see if a building is blocking the view. It makes these geometry problems much faster to solve. 1. What is a sight triangle? Answer: the area that must be kept clear of obstacles so drivers can see approaching traffic at an intersection. Explanation: if an object is inside this triangle, a driver might not see a coming car until it is too late. 2. In a roundabout, who has the right of way? Answer: the vehicles already circulating inside the roundabout. Explanation: drivers entering the circle must yield to those already inside to keep the flow moving. 3. Why do we add a taper to a turn lane? Answer: to give drivers a smooth path to move from the straight lane into the turn lane. Explanation: a taper prevents sudden steering movements and helps maintain a safe speed. 4. What is the main safety benefit of a roundabout over a traditional intersection? Answer: it reduces the severity of crashes by eliminating high-speed, right-angle impacts. 5. If you are calculating the length of a turn lane, what is the storage length? Answer: the space needed to hold the maximum number of cars expected to wait during a red light. Explanation: you want the lane long enough so that waiting cars don't spill back into the through traffic lane. Section 5. Pavement Design and Maintenance. Details, theory and concepts. Roads aren't just black paint on dirt. They are complex structures. We have two main types: flexible, asphalt, and rigid, concrete. Think of flexible pavement like a layer of thick skin. It bends slightly when a heavy truck drives over it. It is made of several layers: the surface, the base, and the sub-base. The goal is to spread the weight of the truck so the dirt underneath doesn't get crushed. We use a number called the structural number, SN, to measure how strong the road is. Rigid pavement, concrete, works like a bridge. It is very stiff and spreads the weight over a huge area. Concrete lasts a long time, but it is expensive to build and hard to fix. A big part of the exam is pavement distresses. Alligator cracking. This looks like the skin of an alligator. It means the base underneath has failed. Rutting. These are the grooves in the road where tires go. It usually happens in hot weather when the asphalt gets soft. Pumping. This happens in concrete roads when water gets under the slab and pumps out the dirt every time a car drives over a joint. In my Udemy practice test, I have photos of different road cracks and ask you to identify the cause. This is a very common type of question on the P exam. Practice questions. 1. What is the primary difference between flexible and rigid pavement? Answer: flexible pavement bends under loads, while rigid pavement acts like a solid slab to distribute weight. Explanation: flexible is typically asphalt. Rigid is typically Portland cement concrete, PCC. 2. What does alligator cracking usually indicate? Answer: a failure in the base or sub-base layers under the asphalt. Explanation: it is a sign of structural fatigue, meaning the road can no longer support the weight of the traffic. 3. Why do we put dowel bars in concrete road joints? Answer: to help transfer the weight of a vehicle from one slab to the next. Explanation: dowel bars allow the slabs to move with temperature changes but keep them aligned so the road stays smooth. 4. What is ESAL? Answer: equivalent single axle load. Explanation: we convert all different vehicles, cars, buses, trucks, into a standard 18,000-pound axle to calculate how much wear and tear the road will take. 5. What causes rutting in asphalt? Answer: permanent deformation in the wheel paths, often due to heavy loads or soft mix. Explanation: it creates dangerous channels that can hold water and cause cars to hydroplane. Section 6. Road materials and soil mechanics. Details, theory and concepts. To build a good road, you need to know your dirt. In transportation, we call this geotechnical engineering. We classify soil based on the size of the pieces. They are great for roads because water drains through them easily. They are terrible for roads because they hold water like a sponge and get soft when it rains. The exam will ask you about the Proctor test. If the dirt is too dry, it won't stick together. If it is too wet, it becomes mud. You want the Goldilocks amount of water so you can pack it down, compact it, to its maximum density. We also test the aggregate, the rocks, used in asphalt. We use the Los Angeles abrasion test to see if the rocks are tough. We put the rocks in a big drum with steel balls and spin it. If the rocks turn to dust, they are too soft for a highway. I have a soil and rock cheat sheet in my Etsy visual guide. It helps you quickly identify soil types, like A1 or A7, using the AASHTO system, which is a huge time saver during the morning session of the exam. Practice questions. 1. Why is clay a poor material for a road base? Answer. It holds water and expands or shrinks, which causes the road to crack. Explanation. Clay is unstable, meaning its strength changes too much when it gets wet or dry. 2. What is the goal of the Proctor test? Answer. To find the perfect amount of water, moisture, needed to pack the soil as tightly as possible. Explanation. Denser soil provides a stronger foundation for the road. 3. In a sieve analysis, what does a no 200 sieve do? Answer. It separates coarse materials, sand, gravel, from fine materials, silt, clay. 4. What is liquid limit? Answer. The moisture content at which a soil starts to behave like a liquid. Explanation. It is a key part of the Atterberg limits used to classify how soil reacts to water. 5. Why do we want angular rocks instead of round rocks in asphalt? Answer. Angular rocks lock together better, providing more strength and stability. Explanation. Round rocks, like river stones, slide past each other, making the road more likely to shift or rut. And that brings us to the end of our deep dive into intersections, pavements, and materials. You are building a very solid foundation for your PE exam prep. Make sure you don't miss out on the resources below, the full course. Get every single section and expert explanation. Udemy practice test. Practice with realistic questions and full-length exams. Etsy visual guide. Download my easy-to-follow diagrams for soil and pavement layers. You are one step closer to those 2 letters after your name. Keep at it, and I'll see you in the next one.